Tricks to solve problems on connected bodies. To solve the connected bodies problems easy way. Now consider this type of surface. This is a double inclined plane and the planes are at an angle theta 1 and theta 2. Masses are m1 and m2 on them on the inclined surfaces, and these two are connected by a single string over the pulley. The tension in the string can be calculated using the equation T is equal to mu into G into sine theta 1 plus sine theta 2. That is mu G sine theta 1 plus sine theta 2. Here mu is not the coefficient of friction. It is nothing but the reduced mass. It is the reduced mass which is equal to m1 m2 by m1 plus m2. Now the reduced mass is simply called as the two body problems converted into a single body problem. Now using this equation we can calculate simply the tension in most of the cases. Now consider the case of a towed machine. Now here these are the two masses m1 and m2 are connected by a single string which is over the pulley, and the pulley is connected rigid to a rigid support. Now this a towed machine can be obtained from this diagram. If theta 1 is equal to theta 2 is equal to 90 degrees, then these two sides are now becomes like this. These two bodies, these two sides are now turns like this, and they become like this. Now at 90 degrees they become like this. Now if theta 1 is equal to theta 2 is equal to 90 degrees, sin theta 1 and sin theta 2 becomes 1. Therefore the resultant tension is equal to T is equal to 2 mu G. From this equation I am writing this equation. Now what about the tension in this string? Tension in the string. Now in this the reduced mass is equal to, simply we can consider it as m1 m2 by m1 plus m2. Therefore the tension is equal to 2 m1 m2 by m1 plus m2 into G. And what about the acceleration? Acceleration is simply calculated by taking the forward difference in the forward force minus backward force. Difference in the forward force and the backward force by total mass. Forward force is nothing but m1 G and backward is nothing but m2 G. Therefore the acceleration is equal to forward force minus backward force by total mass. That is m1 minus m2 by m1 plus m2 into G. Now this is about this acceleration. This is about the acceleration. Now case 2. Now the condition is like this. Now here the two bodies m1 and m2 are connected one side of the pulley, and this third mass m3 is connected to the other side of the pulley. Now these m1, m2 and m3 are connected to a single string, and to the another string m1 mass is connected. Therefore the tensions are different. Now in this string suppose the tension is T1, and in this part of the string the tension is equal to T2. Now if m1 m2 m1 plus m2 total mass here is greater than this m3, then this combined mass is moves in the downward direction, that is the acceleration in the downward direction, and this side acceleration body is moving in the upward direction, so it is the acceleration. What about the resultant acceleration in this case? Now acceleration is equal to forward force minus backward force by total mass. Forward force is this is forward force m1 plus m2 into G, minus backward is m3, m1 plus m2 in m2 minus m3 by total mass m1 plus m2 plus m3 into G. This is the acceleration of the body. Now we have to calculate the tension T1 and T2. Now if we consider this T1, the tension T1 is equal to 2 mu G, where mu is the reduced mass. Now what about the masses in this case? How can we write this reduced mass equation now? For this I consider this as the single mass. This is one mass and this is the another mass. The total mass m1 m2 is considered as a single. Therefore I can write this reduced mass equation as this m3 into m1 plus m2 total mass by the total masses m1 plus m2 plus m3. So this is the reduced mass equation in this case. Therefore the tension T1 is equal to 2 mg is equal to 2 m3 into m1 plus m2 by m1 plus m2 plus m3 into g. This is the nothing but the tension T1. Now here and here in these two parts it is clear the tension is equal to T1. Now come to this T2. What about the tension in this part of this string? This T2 for this the reduced mass can be written by considering this mass as well as this mass. Now this mass does not play any role. These two masses only we will consider to write the reduced mass. Therefore the reduced mass is equal to m1 m3 by m1 plus m3. Therefore the tension is equal to 2 m1 m3 by m1 plus m3. This equation again written by using this equation. So the tension T2 in the string is equal to 2 m1 m3 by m1 plus m3 into g. Case 3. Now this is a different case. This is the surface on which 3 bodies are placed. One body, and this is the second body and of the third body. These are the 3 bodies. And the masses are m1 or m, 2m and 3m. 2m and 3m. These 3 masses are connected by a string. And the force is acting in this direction. F is the force acting on this. Now here is the tension. Here is the tension T1 and here is the tension T2. The force is acting in this direction so that all the masses are moves in that direction and the acceleration is in the same direction of the force. Now what about the tensions in this case? What about the tensions in this case? In this case also we use the same equation, that is T is equal to 2 mu g by 2 mu g, where mu is the reduced mass. Where mu is the reduced mass. This reduced mass is equal to product of the masses by total mass. Total mass when it is a 2-body condition. When it is a 2-body condition. Now here we have the 3 bodies of masses m, 2m and 3m. Now how can we calculate the reduced mass here? The reduced mass in this case is equal to, now while calculating this T1, this is nothing but one body of mass m and these 2 bodies are considered as a single body. Single body. This is one body of mass m and this is another body of total mass 5m. M and 5m are connected. Therefore the reduced mass in this case is m 5m by total mass is m plus 5m. Now this is equal to 5m square by 6m. M gets cancelled, therefore 5 by 6m. Now this is the reduced mass. Now using this we can calculate the tension in this part of the connected bodies. That is T1 is equal to 2 mu g. This is equal to 2 into mu is nothing but 5 by 6m into g. Now this is 3. It is equal to 5 by 3 mg. Now this is the tension in this part of this string. Now coming to this part. Now force is acting on this one and we are considering this part. So that here again you have to calculate for the T2, again you have to calculate the reduced mass. For this part, for this tension, the reduced mass is, here we have to consider this mass and as well as this mass. Now simply we ignore this one. So that here this reduced mass is nothing but m1, nothing but m and 3m by the total mass is m plus 2m plus 3 plus m. Total is 6m. Total mass is 6m. Now this is equal to m gets cancelled. This is equal to m by 2. Therefore, the reduced mass is equal to m by 2. Therefore, this T2 is equal to 2 mu g is equal to 2 mu is nothing but m by 2 into g. Now, this is equal to mg. This is equal to mg. This is the reduced mass. This is the tension in this part of this string. So, this is the tension in the first part of the string, and this is the tension in the second part of the string. What about the acceleration in this case? Acceleration is nothing but the forward force minus backward force. So forward force is nothing but F, and the backward force is equal to 0. So forward force minus backward force, that is acceleration, is equal to forward force minus backward force by the total mass is in this case 3m plus 2m, 5m plus m is equal to 6m. So this is nothing but the acceleration in this case. This is the condition. Now here the body m1 is on the inclined surface and the body m2 is on the plane surface. The angle of inclination here is, say suppose it is equal to theta 1. Now these are connected by a string, and it is m1, clear that m1 is greater than m2. Now what about the tension in this string? What about the tension in this string? This tension is nothing but, now here T is equal to mu g sine theta 1 plus sine theta 2. Basic equation here we are considering. Now in this case theta 1, here is the theta 1, and what about this theta 2? It is on the plane surface. So for a plane surface theta 2 is equal to 0. If theta 2 is equal to 0, theta 2 is equal to 0, sine 0 is equal to 0. Therefore, you can write this tension is equal to mu g sine theta 1. Mu g sine theta 1. Mu is the reduced mass. Reduced mass, and in this case you have only the two masses m1 and m2. Therefore, this is written as m1 m2 by m1 plus m2 into sine theta. Sine theta 1. This is our equation. Tension. And what about the acceleration? Acceleration is nothing but the forward force minus backward force. So forward force is nothing but, now this is m1 is greater than m2. Therefore it is moving in this direction, and this is also moves in this direction. There is no backward force. Therefore the acceleration in this case is equal to forward force minus backward force, which is say here is forward force minus backward force by the total, it is nothing but m1 plus m2. Now this is equal to mg sin theta is equal to m1 g sin theta 1 by m1 plus m2